Hello, everyone, and welcome once again to In Vivo Biosystems 17 Minutes of Science. My name is Anna Milinkovich, and today our discussion will focus on science communication in the context of science policy, as well as one possible road from the lab bench to policy communicator. Our guest today is the wonderful Andrea Stathopoulos, who is a neuroscientist turned policy communicator. She's currently serving as the AAAS Science and Technology Policy Fellow with the NSF. So welcome, Andrea, and thank you for joining us today. I'll turn it over to you to give us some background on your experience and what got you here, and then maybe we can tackle some questions from our audience and ourselves at In Vivo. Andrea?
Thanks, Anna. It's great to be here. So as you mentioned, I'm currently serving in a Science and Technology Policy Fellowship program. It's hosted by AAAS. They're the same organization that publishes Science magazine. The application is open. You can apply to be a fellow too. It's a program specifically designed to get PhDs into government. And I don't think I had planned to go into government. I just knew even as a graduate student, I didn't quite want to stay in academia. I studied sort of the intersection of biology and psychology because that's what was interesting to me. And halfway through graduate school, realized I really loved teaching. And so I sort of hung around in academia as an adjunct and visiting professor for a few years after I graduated. And then finally left. This fellowship was the opportunity for me to finally step away. And in the policy fellowship, in my particular role at the National Science Foundation, I happen to be doing a lot of science communication and sort of serving as a liaison from the office where I work and the office within the agency that sort of disseminates information externally to the public and to interested stakeholders. And it's a bigger change than I thought it would be. I'm used to being in the lab and working maybe with a small team. I'm used to being a professor and having sort of free management of my classroom. And now everything I'm doing is incredibly collaborative and requires sort of a lot of checks and balances sort of across the different offices that are all working on projects within the agency. And it's a really weird and different shift. And on top of all of that, I've switched scientific fields a little bit. My degree is in neuroscience, but I'm working in the Directorate for Math and Physical Sciences, which includes everything from chemistry and materials research to physics and astronomy. And so I'm still learning more science.
Oh, that's a bit of a change, definitely. It sounds like from where you started. So actually that launches us into one of the first questions we had from our team and kind of some of the audience. And I should mention before we dive in, I did just start our handy dandy timer. So it is set for 17 minutes now that we're on to questions. But kind of touching back on, you alluded to this, one of the major changes, going from working in a small team, in lab and at the bench to kind of managing your own time and your own group as a professor or lecturer or teacher as a broader scale. Kind of how did that transition come about? And kind of, you mentioned you didn't necessarily know that this is where you wanted to go, but what were some of the maybe earlier feelings you had or kind of thoughts that went through your mind as you were finishing up in your graduate space and you kind of saw the end of your potentially academic tenure as a graduate student that made you think like, maybe academia is not where I want to head in the immediate or long-term future?
That's a great question because I thought going into graduate school that academia is exactly where I wanted to be. I imagined this career where I will spend my life discovering new things. And I really enjoy bench work. I love working with animals. I can pipette happily for hours. What I didn't love was failed experiments over and over again. And I sort of surprised myself by finding out that I really loved teaching when I was a TA and was just sort of thought to myself, well, because science is really cool and I like sharing cool science with people. Like I can pursue maybe a more teaching focused career trajectory rather than a bench researcher career trajectory. And so that's what I initially did immediately after graduate school. I was at a small liberal arts college. And so I was doing this much research and mostly teaching. that was sort of the inspiration again for pursuing this fellowship opportunity. I want to share cool science with people who need to learn it. And that could be a college student audience, but it could also be the federal government, where it's really important that we have evidence-backed policies and legislation. And you get that by pairing up science expertise with those government officials to hopefully be able to provide, the right balance of politics with the right balance of what does the evidence say. And that was the inspiration for pursuing the fellowship. And I still feel like, okay, maybe I'm not, writing legislation or anything like that, but I'm still doing that cool science communication and sharing cool science with people that I think should be hearing it.
That's awesome. So it is still a little bit, and maybe I'm a little naive, but to my mind, kind of considered a non-traditional role, right? Coming out of a graduate program. So can you speak a little bit to your experience making that transition and kind of, the support you had or maybe didn't have?
Yeah, and the more, now that I've been in this fellowship for about a year, the more I'm realizing, oh, it took me a long time to actually get out of academia. I knew I didn't want to stay, 2 or 3 years into graduate school, and it just took me this long to make that transition finally. I applied to all kinds of things when I graduated: postdoc positions, faculty positions, positions at zoos, positions in marketing, pharmaceuticals, you name it. Landed a faculty position, and so sort of started there. My graduate school advisor actually was a mathematician, so I'm sort of circling back to that. He was really supportive of letting me pursue whatever I was most interested in, but right away also admitted that he could not help me. He looked at me and all of his other recent graduates and said, gosh, it's rough out there on the academic job market for you guys. That wasn't like this for me when I started a postdoc, however many years ago. I'll write you rec letters, but that's the most I can do to help you. And so it was a long process of me exploring job options and finding out what was available outside academia that still overlapped with my skill set and my interests, where I could make the most use of this PhD training I had, but apply it somewhere else. And that was just a lot of, learning and growing on my own, kind of, and figuring it out. And there's increasingly networks on LinkedIn and things like that, where you can find that sort of support if you're not getting it, say, from a graduate advisor. And I sort of lament that there wasn't more programming that like my graduate school was able to provide on career options. I think I see it happening more now, sort of 5 years removed from graduate school. But it took me a couple years to sort of figure out what else I wanted to do, but I'm making it here now.
Yeah. Well, that's fantastic. It's, on the one hand, really great to have an advisor be so candid and say, I support what you want to do, but it is so far outside of my kind of expertise in terms of being able to help you that, I will do anything I can, although that might not be much. But on the other hand, I can totally see it being a little bit daunting, because now you very literally are paving your own way. You don't have necessarily, your advisors, chum from grad school that you take on a postdoc in their lab and it's all very smooth transition.
Everyone else that you speak with. So, I was a visiting professor for a few years, and all of my colleagues around me had been in their positions for years and years and decades. And, they couldn't even offer useful junior career advice if I wanted to leave the university, because that's all they had known. And I think they too were very supportive with sort of this, like, oh my God, you're so brave going out into the great unknown and like leaving our little comfort bubble of academia. So yeah, I was lucky in that everyone that I interacted with was supportive of me, but it also, the support could only go so far, because no one could sort of point me in the right direction or, hand me a contact that would get me to the next career step. A lot of that was trial and error job applications on my own. No,
that definitely takes a lot of guts, and you can definitely see, it it's inspiring for sure, and just
Thank you.
to see someone forge their own way like that. But I did kind of want to touch back to, you mentioned, you know, specifically wanting to still be able to leverage and use the skills that you used in your, you know, PhD training. So if we can touch on that, kind of what in your current role now, what do you think are some of the maybe more important skills that you can bring to the position from your academic time?
So I still do a lot of, like, I think in an academic career path, you do a lot of communication. It's just maybe a lot more technical, what gets written in a scientific journal versus something that's going to be published for more general public consumption. But learning to speak a different scientific language, I think, is a really useful skill. So in my graduate lab, I was doing biology and neuroscience, but my advisor was actually a mathematician. And he had sort of inherited this biology lab because mathematicians love anything in biology that oscillates. It's really easy to fit models to when it, you know, hormones do this all the time. So from the get-go, I was interfacing with modelers and experimentalists from different backgrounds. And so I was sort of raised in an academic environment where there was a lot of crosstalk like that. It's just one more step additionally to then expand that communication skill to talking to people who don't know the science, which is really what you do in the classroom, right? When you're teaching students, they walk in and they don't know anything yet. You have to teach it to them. So it's not the same as dumbing something down. I think it takes a little bit more skill to be able to explain something complicated without watering it down and eliminating some of those facts, but just explaining the facts in a much more accessible way. And that's just like any other skill, something you get better at doing with practice. And I don't know much about, you know, physics and astronomy, but a lot of the work that I'm doing now in my office is on scientific topics that I don't have a training background in. That doesn't matter because I still have a background as a scientist and I can read anything you hand me and digest it to some degree. And so this ability to pick up new skills quickly and to just learn complicated topics, even if they're outside your technical expertise, is a skill that I think all scientists have. Just you might not always have that opportunity to use that skill if you're staying sort of within your field or within academia. So I think a big trick is just learning how to learn and then being able to apply that to literally whatever you're doing.
No, that's a fantastic point, is just kind of how that academic PhD training really ideally would teach you also how to learn. And for every individual person, that's a little bit different, kind of how
it's the scientific method, right? You have a hypothesis, you test it out, see if it works. If it doesn't work, you're back to the drawing board. And I think that applies to most things that we try and do. In your career, if you're looking to transition, you keep hitting roadblocks. I mean, it's just the same as being at the bench and hitting roadblocks with your experiments. You just change up your hypothesis and you try again. And being able to sort of like, you know, adapt on the fly like that. And again, keep learning new information and sort of reanalyzing what you're doing at the simplest level is the skill you're learning as a graduate student.
No, it's a very good way of looking at it. And it touches back on, you know, when we spoke earlier, you made a point about kind of resilience and that being a very, very big part of development as a graduate student and kind of something that you could take in, like you said, in whatever next career path you chose. So can you touch on that a little bit?
Yeah, and I mean, it's not like I'm some career expert or a senior in my career. I'm 5 years out of my PhD, but yeah, I mean, a PhD is, you know, banging your head against the wall until the experiments work sometimes. And I think a lot of the training that is useful outside academia, we don't have names for it sort of in the lab. So learning how to learn complex skills is useful. But in graduate school, it's just important that you learn your field and building up of resilience and being able to struggle repeatedly until something is done. Most people get discouraged by that. Scientists thirst for it, though. we go after the crazy projects that are too difficult and we'll spend years working on them. Like if that's not a positive career trait that you'll crack that nut, I mean, I don't know what is. It's just, we think of it as like normal and frustrating as part of the job of being a scientist, but in any other career field, that's gold.
That's a really great way of kind of framing this whole idea of, what you take out of your training and what you can do with it.
Yeah, I still have to remind myself of that because, in my new job, I am learning a lot of new things that are different from how I'm used to doing things. And I can get frustrated. And I just have to remind myself, like, I am learning. I am back to square one. In the classroom, I am the expert, but in this fellowship position, it's a fellowship. I'm a trainee, I'm learning. And I don't want to say it's like weird and awkward to be back in that role, but it helps me to remember that this is the point of the fellowship. It's for me to grow and learn a broader skill set. And that's the exciting part about it.
That's awesome. That you kind of back to learning again, and kind of the idea of ideally people would continue to grow and develop and learn kind of as they progress through, their careers or lives in general. But so
that's always what I sort of wanted to do with my dream career, I think, was always keep learning. And that's where I thought science could get me.
Yeah. No, and it looks like it has so far. So, but kind of, I'm going to change tack a little bit and get a little bit more into the policy. So kind of one of the things that we touched on also in our prior communications was your idea of kind of wanting to see more women in science and wanting to improve kind of public science literacy. So what are some of the current challenges that you see in those spaces?
Gave me the hard question last. So
it'll be the last one, I swear.
So I think on the public literacy side, it's again this sort of misconception that like, oh, science is only for smart people, or science is really hard and I can't possibly learn that. But I mean, if you grew up watching the Magic School Bus or something, like, that science is for everyone. And I think it just takes, again, some awareness and some communication skills to take something that's really technical and nitty gritty and detailed that you'd prepare for a publication and make it cool and interesting and relatable for the public, who at the end of the day is probably, with their tax money paying for your grants and might appreciate knowing what's going on. There's so many applications for science, and the underlying science is probably poorly understood by most people. So I think it's like part of your job as a scientist to share the research that you're doing, not just with your scientific community, but with your community, like with other people. I just think it's so important that people have a good appreciation of everything that science can do for them across the spectrum of technology and medicine and you name it. Mm-hmm. On the women in STEM side of things, it was just always a passion because, well, I am a woman in STEM. I studied female fertility hormones in graduate school, which are still poorly understood just because they're, too complicated to bother studying. So not many people have bothered. And again, it just seems like this stuff is important. This stuff is cool. Like, we need to know more about it and we need to share what we're learning. It just has always seemed like something crucial to me. And if I can make incremental forward progress on that in my career, then I'll take it as a win.
Okay. That makes sense. So like that, every little step is progress. So we actually have just 1 minute left. So I do have one more question for you. I lied.
All right.
But kind of going back to the concept of community, and you mentioned, as a scientist, one of our kind of responsibilities is not only to share our findings with our fellow scientists and our scientific community, but our, broader community as a whole, the global community, if you will. So I guess this question goes back to kind of, in order to communicate that, kind of why choose government and why choose policy as a kind of the venue in which you would work and work to communicate?
For me, again, my inspiration in pursuing first a teaching career and then this policy fellowship was I really love science and think it's cool, and I think other people should also think it's cool, and I want to share it with them so that they get as excited as I do. So that just enthusiasm has spilled over into, I think, my career choices. I figured, students at college are going to get an education. The government seemed like a sector where there was increasing need for science expertise to help inform not just policy, but I don't know, policy with a small p, I guess I'll say, just how agencies are run internally. There's a lot of sort of internal questions that have nothing to do with how the national rollout of research enterprise functions, that still requires that you have data to know how much money is going there, how many people are being supported, workforce training. There's numbers and data on that. So even just doing a little bit of data analytics helps, let alone, all of the statistics and data that we could use to back up, why you should increase funding for this or increase funding for that, or predict how certain laws or policies might have an impact. It just seemed like there's like a wealth of applications of science in the government. And again, it sort of doesn't matter what field of science. There's some sector in the government where they're going to be curious about, well, how does that matter for funding or for health or for defense or for, you name it. There's this ginormous world out there of applications beyond the bench that I feel like I've just stuck my toe into. I'm not sure if I've answered your question.
No, I mean, it's definitely a good start. And I think that's a perfect kind of comment to end on, is that there's this whole kind of wealth and breadth of opportunity to make a difference with a science background. It's in government, policy, communication, teaching, anything and everything in between. So
yeah, it's not maybe my original plan. It's just I've sort of slightly veered in a different direction than maybe what I planned on from the beginning. But it's still all cool science to me.
Yeah. It's cool science, and the opportunities are out there to make a difference. So with that, we're, I think, well over 17 minutes. So I'm going to leave us and wrap it up on that kind of awesome, high inspirational note. So thank you again, Andrea, for joining us. And 17 minutes of science will be back next week. Thank you, everyone. Bye-bye.